This is Chapter 2, Section 2, Part A. So we will break it up into a Part A and a Part B. And we're going to look at units of measurement today. And to start off with, we've got the word quantity. A quantity is represented by a number and a unit. So whenever we get into our math problems, you're going to realize that 99% of the numbers so that we know what we're actually American, and you're over at 100 out on the highway, and you're thinking to yourself, 100? Oh my, kilometers per hour, which in America would be, they were actually doing the speed limit. Again, as we go throughout this, units do matter, and you have several that you're going to need to learn because we're going to move on over into the SI system. So the next two slides that you see are going to be showing you the base SI units and prefixes. You have a copy of these already, and we will get into even more before Section 2 is out. So as you're looking at yours right here, you do have a chart that is called the SI base units, and I do want to make sure that you're looking at the correct one. There were more than 5 that were on your chart, but we're going to look at the first 5, with the first 3 within this chapter being the most important, but we will work with temperature and amount here very soon. So, for length, its symbol is an L, its base unit is the meter, and its abbreviation is a lowercase m. You're going to see the lowercase m symbol used for multiple things. Just within this section, we're going to be showing it at least 3 times. So it's going to be important that you understand which lowercase m goes where and means what. I'm going to go ahead and put up all of these so that I can do some writing. So we've got length, again, measured using the meter. So again, our base units. Mass, there's another lowercase m. It's measured in the kilogram, abbreviated kg. Time is measured in seconds. Temperature in Kelvin, because later on we'll work with gases and calculations with them, and it's on the Kelvin temperature scale. And then amount of substance is measured with the mole, abbreviated mole, MOL. If we were to look at, again, these are SI units. If we were to look at English units, ones that, again, most of you are going to be much more familiar with. If we were looking at base units in the English system, or just units, period, within the English system, we would measure length in feet, say, or inches, yards, miles. That's the kind of things we're looking at there. Mass is still going to be measured in grams. We can't think pounds. Pounds is more like weight, and that's a force. So there is going to be a distinction there. So we're going to leave grams right where it's at. We still measure time in seconds. Temperature, you know that we like to work in Fahrenheit here in the U.S. The rest of the world, they're going to work on the Celsius scale. But in science, we're going to work on the Kelvin scale. And that'll make more sense later why Kelvin and not Celsius or Fahrenheit. And then again, amount of substance, everybody uses the mole. So again, we've got meter, kilogram, but the gram part of that, because we're going to look at prefixes here momentarily, seconds, Kelvin, and mole. Make sure that you're very familiar with any abbreviations that go with these. Again, meter, grams, the important part, even though kilo is used as a base, seconds, Kelvin, and mole. So you also have this table. This is the SI prefixes. This one's going to lack a few that you have within your particular table. We are going to concentrate on mega through micro, and it's even missing, a couple more up through here. But mega through micro are going to be the ones that we're going to focus on. And you can see your base unit there. There is no symbol because a base is 10 to the 0. And 10 to the 0 equals 1. The rest of these, it's going to be highly important that you look at these factors, these exponents that are out here beside each of the prefixes so that we can use these in calculations later. Again, we will get to this much more in depth also within class and even within 2.2b once we get to those particular ones. Okay, derived units. You do have a third table that is called SI derived units, and this is where we combine some of those base units we were looking at. So those first 5 base units, length, mass, time, temperature, and amount of substance, how can we combine those? Your table is going to give you many more options. I'm going to go over a couple here. One of them is volume. Volume, if you were to look in your math class and your math teacher said, hey, how would you calculate volume? Most of you would say, oh, it's length times width times height if you're talking about a solid substance, and that's great. But even width and height are just another type of length measurement in a different direction. So if we were to take the base units that go with those, each of these measured in meters as our unit, well, meter times meter times meter is meter cubed. Centi is a prefix added on, so you'll see that volume commonly for this class, since we're going to be sticking with the SI system, you're going to see meter cubed or centimeter cubed appear multiple times. Over here are some equality statements. Make sure you also get these written down. 1 centimeter cubed equals 1 milliliter. So that's a lowercase m, a capital L. So 1 centimeter cubed equals 1 milliliter. If you've ever heard, say within one of the shows that you might watch on TV, like an ER, Grey's Anatomy, something like that, that has doctors running around and they're trying to pump some medicine into someone, and maybe the doctor yells, give me 5 cc stat of such and such drug. cc's means cubic centimeters. I'm pronouncing it as centimeters cubed. We are talking about the same thing, which is this value right here. So 5 centimeters cubed would be the same as 5 milliliters. That is roughly the same as our teaspoon, okay? So roughly the same as our teaspoon if you're talking English unit. And then you've got 1 decimeter cubed equals 1 liter. If you think of a 2-liter Coke bottle, so you've seen those Coke bottles in plenty of stores, that's 2 liters. So if you cut that in half, that's 1 liter. So if it's a 2-liter Coke bottle, it's also 2 decimeters cubed. Make sure that you can do volume calculations. Another derived unit on your sheet is density. We're going to work with density right now. Density is mass per volume, so mass is divided by volume, and they are giving you the SI units typically seen. So the official SI unit is kilograms, which is a mass unit, divided by meters cubed, which is a volume unit. We can also do grams per centimeter cubed. These are not the only 2 options. You can put any prefix in front of grams. You can put any prefix in front of meter cubed to get you a variety of density units. I'm just showing you the 2 most common ones here. So as we look at this right here, density equals mass over volume. Etch this into your brain. You need to know it. I'm also going to show you another way people memorize this, and we call it the density triangle. I'll write it up here at the top. The density triangle, breaking it up here and here. So if I look at my equation, I notice that density is off to the left, so I'm putting it to the left. Mass is on top, volume is on bottom. We call it mountain over valley. Mountain over valley. So whatever way you want to remember that works for me. And when we start doing calculations with this, mountain over valley, this is like a long divide line, so that's mass divided by volume to give you density. If you were trying to find volume, it would be mass divided by density equals volume. And if you were looking for mass, then it would be density times volume equals your mass. This is simple algebra. I'm just using letters instead of XYZ. I have DMV. Take great notes of this part right here. My goal is to do a in-person lab with y'all in class. You're going to have some charting that you're going to have to do. And this one right here, because density is equal to mass over volume, on the xy axis we have mass and volume. Mass is on the y-axis, volume is on the x-axis. If I were to take the slope of this line, y'all should know in your math class, slope, if I asked you what slope was, a lot of you would say rise over run. That's really good. Rise is the change in y. Run is the change in x. So I have delta y over delta x. And I'm going ahead and making the correlation for you. But again, this is rise over run. Since mass is shown there on the y-axis, that should be a lowercase m for mass. We have mass there, and volume is on the x-axis. I put volume. Well, what this is saying is once you find slope, which is your rise over your run, you have essentially found the density of your substance. Density of your substance. If I break out the rise over run just to make sure you have what you're supposed to have, that change in y, that's like saying y2 minus y1. Change in x is going to be x2 minus x1. And if I were to plot that over there, I'm going to make my two dots where you did your rise and your run. As I come down here, I don't care which point you label 1 or 2 as long as you stick appropriately with them. So I'm going to label this point 2. This is point 1. So this would be x2, and this would be x1. As I come over here, this would be y1, and right over here, this would be y2. Again, if you can't remember all of this, and just going based on the past, what I've normally run into with students, make sure you get every single bit of this into your notes. You are going to have to perform this and do this in a lab once we're through with this chapter. So don't forget. Okay, I have added a figure that was not in the PowerPoint. This is coming straight out of your book, and it's looking at densities of some familiar materials. You have everything from your typical water. You have cork, butter, ice. You have some metals off in there. You've got other liquids like your alcohol, kerosene, and then it gets on into milk and mercury. Mercury is a metal that is a liquid at room temperature. So as I'm looking at the different densities of each of these, hopefully you remember, but as a refresher, the lower the density, if you put two of these together, and they're at two different densities, the lower density substance will float in the more dense substance. So if I were to ask you a few questions about this, as far as which one's going to float, let's look at cork with water. And we will circle the one that will float. So look at that. And hopefully you've got that cork will float on water. That's about like saying wood floats on water. If I go back and I look at a couple other ones, how about we've got water and lead. Water with lead. And this, not so much a matter of floating because we know what's going to happen, but the lead will sink. The lead will sink because it is more dense. And now if you were to look at, let's say you had a drop of mercury with water, the mercury would also sink. So just be familiar with this. I know you'll see a couple questions here and there in class about this. Make sure you understand how to read this density chart. You do not memorize any of the values though. We're going to work out a couple examples. be sure to get everything in these examples ready. You do need your baby calculator, so I've introduced you to those again and asked you to buy one of those. I have some in class too, but you will need that out in class. We will not use our scientific calculators. So an object has a volume of 825 centimeters cubed and a density of 13.6 grams per centimeter cubed. Find its mass. Just a couple things to point out. Units, you're getting very familiar with units. So these units behind the number, centimeters cubed is a volume unit. And then grams per centimeters cubed is a density unit. The problems will not always say volume of, density of. They might just give out the information without explicitly telling you what it is it's measuring, because they're going to want you to use the units to identify the number that is in front. So first off, I want you to write down your given information. So again, volume is 825 centimeters cubed. Density is 13.6 grams per centimeter cubed, and we are looking for mass. Again, lowercase m for the mass here. And we're going to set up our problem. So I've got written for you the density equation and the density triangle. Since it says find its mass, let's go ahead. I don't care which way you go about this algebra problem. You can come up here and just put straight in density equals mass over volume, plug in your information, rearrange it in your head, and get going. Or you can rearrange it to start with and then plug in the information and go. Either way, I'm going to want to see an equation. So either the original equation we have, which is D equals M over V, the density triangle, or the rearranged equation before you put in information. So as I look at this, since it says find mass, here's what I would do. And if I were using the density triangle, I would cover up mass. So that means it has to be D times V to give me mass. So this rearranged is density times volume. Again, I don't care which way you go about doing this. Plugging it in, rearranging, it is algebra. But again, I don't know how comfortable you are with your algebra. So I'm going to go ahead and look at this. So mass equals, I'm plugging in the density of 13.6 grams per centimeter cubed. I am plugging in the volume of 825 centimeters cubed. If I look at my units, you should be able to tell the units of centimeter cubed and centimeter cubed. One's in the numerator, one in the denominator, cancel. So your final answer, 13.6 times 825, is 11,220 grams. Before the chapter's out, we'll learn about significant figures. So again, I have an equation. I've put my information in it. I have an answer with units, the appropriate units. That is all of the work I expect to see. If you have to show any more intermediate math for you, then you do so. Here's one more example. Again, make sure you get everything written down. A liquid has a density of 0.87 grams per milliliter. What volume is occupied by 25 grams of the liquid? So this one I like just because they don't explicitly tell you what some of the things are. They do say density of 0.87 grams per milliliter. So if I'm writing down my given information, I have a density of 0.87 grams per milliliter. Grams is a mass, milliliters is volume, so mass over volume is a density unit. What volume? Well, it's telling you right there, it wants you to find volume is occupied by 25 grams of liquid. You have to recognize grams is a mass unit, so the mass is given as 25 grams. So we're going to be solving for volume. Again, we have our initial equation, density is mass over volume. We also have our density triangle, mountain over valley. So if I come up here and I put in density equals mass over volume, And I want to rearrange it for volume. That's what we're solving for. Cover it up. Well, it must be mass divided by density. So volume equals mass divided by density. Again, I don't care which way you put this stuff in, but it needs to be put in appropriately. I'm going to put it into the original one this time instead of the one that was given. So density is equal to 0.87 grams per milliliter. Mass is equal to 25 grams. And then volume is what we are solving for. I hope that you see, I'm going to draw some arrows, because maybe you don't, just to see how it really is coming out to this equation. We want to get volume out of the numerator, out of the denominator. So you multiply both sides by volume so that it cancels there. And then if you wanted to get volume all by itself, you would have to divide both sides by the 0.87. That is how density gets into the denominator and volume is left over to the side. Because again, this would cancel now and you would have your 25 divided by 0.87 or mass over density. So, coming up with our final answer, volume is equal to 25 grams divided by 0.87 grams per milliliter. I'm looking at the units right now. Grams divided by grams, that definitely cancels. So I'm going to go ahead and mark through those. Grams and grams cancels. But notice milliliter is in the denominator of a denominator. Essentially, that brings it straight back to the numerator. I'm not going to show you the math on how that is, but if you know the whole keep it, change it, flip it, that works in this particular case. But if you do have your unit in the denominator of a denominator, it ends up in the numerator for your answer. So 25 divided by 0.87 gives you roughly 29 milliliters. Again, we'll talk about significant figures later. So I have shown you a lot of intermediate math on this particular example. If you understand the algebra, great. I want to see an equation, your information in it, answer with units. But if you need to show all of that intermediate math for yourself, please show it so that you can get the correct answer.